Hello and welcome back to our channel. Have you ever wondered if the dazzling northern lights could somehow be connected to the ground shaking beneath our feet? It sounds like something out of science fiction, but what if there's a hidden link between the powerful storms in space and the mysterious tremors deep within our planet? Today, we're embarking on an extraordinary journey to explore the enigmatic forces that trigger geomagnetic storms and deep earthquakes. We'll dive into the heart of our planet and look out into the vastness of space to uncover the complex dance between the Earth's magnetic field, the Sun's volatile activity, and the restless movements of tectonic plates. So, what exactly is a geomagnetic storm? Picture this. Our Sun, a colossal nuclear furnace, doesn't just send us light and heat. It also constantly releases a stream of charged particles called the solar wind. Sometimes the Sun unleashes massive, powerful bursts of plasma and magnetic fields known as coronal mass ejections, or CMEs. When one of these CMEs hurtles towards Earth and collides with our planet's protective magnetic shield, the magnetosphere, it can cause a major disturbance. This is a geomagnetic storm. The most beautiful effect is the aurora, the northern and southern lights. But these storms can also disrupt our power grids, satellite communications, and navigation systems. They are, quite literally, space weather events with real-world consequences. Now let's travel from the outer reaches of our atmosphere to the depths of the Earth's crust. Earthquakes are typically caused by the shifting of tectonic plates. Most of these occur relatively close to the surface in the crust or upper mantle. But there's another, more mysterious kind: deep earthquakes. These tremors originate hundreds of kilometers below the surface in a region where the intense pressure and heat should make the rock flow like thick molasses rather than fracture. For decades, scientists have been puzzled about how these deep earthquakes even happen. They are rarer than shallow quakes but can be incredibly powerful, releasing immense energy from the planet's interior. The mechanisms behind them have been one of the great unsolved mysteries in geology. Here's where things get fascinating. For years, these two phenomena, geomagnetic storms from space and deep earthquakes from the Earth's mantle, were studied in completely separate fields. One was the domain of astrophysicists and space weather experts. The other belonged to seismologists and geologists. But recently, a growing body of research has started to connect the dots. Some scientists have observed a curious correlation, a noticeable increase in the number of strong, deep earthquakes following intense geomagnetic activity. Could this just be a coincidence, or is there a genuine physical connection between the energy bombarding our planet from the Sun and the seismic activity deep within it? Let's explore the leading theory, which revolves around something called the piezoelectric effect. You might have encountered this in everyday objects like the igniter on a gas grill. The piezoelectric effect is the ability of certain materials to generate an electric charge in response to applied mechanical stress. Now, imagine this on a planetary scale. Some scientists propose that certain types of rock deep in the Earth's mantle, like quartz, might exhibit similar properties under immense pressure. The theory suggests that the massive electrical currents induced in the Earth's crust and mantle during a major geomagnetic storm could interact with these rock formations. This influx of electrical energy could potentially alter the stress conditions in the rock, possibly pushing already strained areas over the edge and triggering a deep earthquake. It's like an electrical jolt from space is giving the final push to a fault line deep underground that was already on the verge of slipping. To test this hypothesis, researchers have been meticulously analyzing historical data. They compare records of major solar flares and geomagnetic storms with seismic data cataloging earthquakes around the world. One compelling study looked at decades of data and found a statistically significant link between the arrival of high-speed solar wind streams and an increase in global seismicity, particularly for earthquakes with a magnitude of 6 or greater. The correlation appears to be strongest for deep earthquakes, which are less likely to be influenced by surface-level factors. While correlation doesn't equal causation, the patterns are intriguing enough to warrant serious investigation. Scientists are essentially looking for a smoking gun, a clear, repeatable pattern that can't be explained by random chance. Of course, this is a highly controversial and debated topic within the scientific community. Many geophysicists remain skeptical. They argue that the energy from a geomagnetic storm, while significant in our atmosphere and near the surface, would be far too weak to have any meaningful impact hundreds of kilometers deep in the Earth's mantle. The sheer scale of the forces involved in plate tectonics is colossal, and the idea that a flicker of space weather could influence it seems, to some, improbable. Critics point out that the Earth's interior is a very effective electrical conductor, and any induced currents would likely dissipate long before reaching the depths where these quakes originate. They argue that the observed correlations might be statistical flukes or the result of some other, not yet understood terrestrial cycle. Despite the skepticism, the research continues, driven by the profound implications. If a link is definitively proven, it could revolutionize our ability to forecast earthquakes. Imagine a future where space weather forecasts from agencies like NOAA don't just warn pilots and power grid operators, but also give geologists a heads-up about a potentially increased risk of seismic activity in certain regions. This wouldn't allow us to predict the exact time and place of an earthquake, but it could serve as a crucial piece of a larger early warning puzzle, allowing for heightened preparedness in vulnerable areas. Improving our understanding of deep earthquakes is also vital for understanding the fundamental processes that drive our planet, like mantle convection and the recycling of tectonic plates. So where do we stand today? The connection between geomagnetic storms and deep earthquakes remains a tantalizing and active area of research. It's a perfect example of how interconnected our planet is with its cosmic environment. We are not isolated on a quiet blue marble. We are riding a dynamic, electrically charged sphere through a solar system filled with energy. What happens on the Sun, 93 million miles away, may have repercussions not just in our skies but deep within the very ground we stand on. This research challenges us to think holistically, to bridge the gap between geology and astronomy, and to appreciate the intricate and often invisible forces that shape our world. Whether you're a geology enthusiast, a space weather buff, or just someone curious about the world's mysteries, this field of study is one to watch. The quest to understand these hidden triggers is pushing the boundaries of science and revealing just how complex and wonderfully interconnected our universe truly is. What are your thoughts on this? Do you think it's possible for solar storms to trigger earthquakes? Let us know in the comments below. Thank you so much for joining us on this deep dive into one of Earth's most fascinating mysteries. If you enjoyed this exploration and want to learn more about the incredible forces that shape our planet and our universe, please hit that like button and subscribe to our channel. Don't forget to ring the notification bell so you won't miss our next adventure. Thanks for watching and see you next time.